Following the instruction by my group partner, we have had various sessions in which we expand our resource to figure out a new and fresh idea which has not been analyzed previously before in our course content. What we have in mind is deeper understanding of the standard strategies, be it a factor or value strategy in equities, and not grappling with the mere basic momentum in niche sectors. With the endless brainstorming, we arrive at the conclusion. However, tight majority of the strategies that have been analyzed treat only stocks. This led us to an idea of investing some money in non-traditional assets classes. That is when commodity futures raised an eyebrow with us from areas with quantitative strategies demonstrated promising ability. It turns out that there's a great number of global data about supply and demand, the grain of which is indeed predictive of future price movements troubles. Nevertheless, we had not met any widely used method which utilized the relationship of supply or demand imbalances as a signal of motion. It occurred to me that it could be a topical source of investigation. The idea was meant to be collecting the primarily supply side data, such as numbers of production and stocks, along with demand side indicators like industrial activity for a wide range of commodities. Then we build trading signals based on the detected imbalance of supply and demand and check whether a long short portfolio strategy with long position of commodities characterized by supply shortage and short positions of those with supply surplus passes the test. The greatest difficulty was entrepreneurship from constantly appending the required figures over a prolonged period of time. We pulled information from popular data sources such as Fred and some other commodity exchange websites, which are free. Under the circumstances of those datasets, a lot of records were missing or got disconnected with each other, especially different regions and commodities. Since the data collection was not concluded, I had the scaled task to scrape off some information from company as well as the reports released by governments. To begin with, the 4 years long and completely complicated work of cleaning, combining, and merging all such multiple data sources among themselves into one structured data set was the probably most time consuming part of the entire project. I was able to reflect how doing the data wrangling and analytical work of quantitative professionals are daily routine. Then, after I had obtained aggregated 10-year historical data from five commodities consisting of five of a supply chain and demand data collected monthly, it was time us to actualize the prediction part. As my partner and I focused on converting the raw data into delivery hourly signals, we had to spend considerable time refining the precise transformations. This was done through methods such as calculating year over year percentage changes, idealizing imbalances, at the same time and increasing the level of time lag effect, just to note a few. We use pandas and NumPy libraries for dealing with data in Python extensively in all of our operations. And refactoring the software with object-oriented approach, including signal and portfolio classes, assisted to make the system have a clear and modular code as it grew more complicated. Mostly having the trading signals as a basis, we were now able to translate them into a systematic investigation strategy um, or investment plan. We set out to ascertain the Z-score on each commodity supply or demand ratio for each period and simply bet on the commodities that show the largest imbalances and short sold those with the excessive negative sign. In order to convert this logic into strategy, we spread our portfolio in commodities and upscale positions using methods of forecast values and signal strength. I monitored the tape by calculating the cumulative return rates, annualized return metrics, maximum drawdowns, and a bunch of other statistical features, such as skewness, just to note a few. All of that we discovered was not only moderately, but risk-adjusted rewarding. Like Sharp ratio around 0.8, but while we had a consistently weak show in several categories, that was not spread evenly across the commodities in our portfolio. However, this research brought us to delving into the portfolio's risk structures further, where we employed the uh, Pi portfolio ops performance attribution models. What we found was that based on the factors strategy that we studied, the portfolio was positively correlated with the momentum factor, and the portfolio negatively exposure to the basis factor. There was also side factor risks related to having a high concentration of commodities like oil and industrial minerals. And therefore, the other significant part of the study was the process of running variable or various rigorous regression checks and scenarios, primarily in order to be sure that positive outcomes are not trivial and are not just the result of statistical equivalence. Being aware of these pitfalls, we deployed many accepted techniques such as walk-forward optimization and residualized forecasting to ensure the backtests are not relying on any possible misleading results. Thank you so much.